Welcome all. Today we are just going to see about the topic name called environment and types of environment. So before going to the types of environment, what is meant by environment? Environment plays a major role in artificial intelligence. An environment is the surrounding world or situation in which an intelligent agent operates. So the agent perceives the environment through the sensors and also performs action through actuators to achieve the specific goals. So the types of environment, or we can tell it as an examples, real-time example for each and every environment is first we can take it as in four parameters: agent, sensor, actuator, environment. Agent will be often self-driving car. Sensor will be often whatever the camera, GPS and LiDAR we are using. Actuator will be often steering, brakes and controlled by the accelerator. Environment will be of that you are driving in a self-driving car. It will be of road, traffic signals, pedestrians, other vehicles, and according to the climatic condition, that is, we can tell it as a weather condition. These are all the environment. Let me see about the topic called types of environment. There are different types of environment available. One will be often fully observable versus partially observable, deterministic and stochastic environment, episodic and sequential environment, single agent and multi-agent environment, static and dynamic environment, and discrete and continuous environment. So let me see next slide. So first we are just going to see about the first thing, that the first environment, fully observable and partially observable. So fully observable is that, so fully observable, so the agent can obtain complete information about the current state of the environment. So here the agent can always see the entire state of the environment. So no hidden information that can be exist over in fully observable. So let me take it as an chess game. So since example is chess, so chess it is a two-player game. So the player one and player two. So whatever we are just going to play the game, so that we already know about it. Player one will be moving each and every coin will be known about the player 2. Similar like that, player 2 will be known about it, and each and everything whatever the moves that can be moved from the player 1, that can be visible to it. So that is exactly the concept of fully observable. The other example that we can tell it as an tic-tac-toe. So tic-tac-toe is a 3 cross 3 matrix. So it is also similar to player 1 and player 2. So the player 1 will be of moving with, actually we can select two random symbols like it. One will be of a circle and another will be of an X. So the main ultimate goal for the particular tic-tac-toe as well as chess is either win or lose, and it will be often draw. So each and every agent that can be sees the entire state of the environment. So each and every moves that can be known by the player 1 or player 2, so that can be visible, and each and every current state of the environment is known about the player 1 and player 2, about each and every information that can be moved to it. So that is about the fully observable. Next we are just going to see about the partially observable. Partially observable is that it is an agent that can never see the entire state of an environment, so that cannot access all the information about the environment. Some information may be hidden or it can be of uncertain. So the good example we can tell it as an card game. So card game we can take it as an 52 cards are there. So it is also, you can take it, actually it is not a two player, it will be often multiple number of players we can use the card. So we are just going to have a 52 cards, 52 packets of cards in a card game. So each and every player will be having each and every cards by shuffling each and everything. There will be of a diamond, clever, everything that will be of having. So an agent cannot see the entire set of the information. So some information may be hidden or uncertain. So other one thing, medical diagnosis system is also a good example for your partially observable environment. So this is about the fully observable as well as partially observable. So next is we are just going to see about the deterministic or stochastic environment. So deterministic environment, so it is one type of an state. We are just having the next state is completely determined by the current state and the action. No randomness is involved in your particular current state or action. So an agent current state is and also selected action can completely determine the whatever the next state of the environment that we are just going to use. So we can tell it as an good example is that is of tic-tac-toe is one of the good example for deterministic. So why? Because it is a two-player game. So wherever we are just going to set the current state based on the player 1 and player 2, they will be moved according to the current state, and selected action will be done whatever the moves that can be done with the player 1 or player 2. The ultimate goal is either win or lose or draw the game. So this is about the uh, deterministic environment. The other example that we can tell it as in chess is also one of the good example for deterministic environment, and solving a mathematical equation. So let me take it as a quadratic equation as a good example. So for each and everything we'll be having a equation like a scenario. So that scenario will be converted into the factors and we'll be getting the solution. So x square plus 9x plus 6 equal to 0. So you'll be getting the value of x while calculating with the solution for it. So that can be applied into the equation, and finally you'll be get the particular current state, and next state will be often to determine the next state of the environment. So this is about the deterministic. So next type of an environment is an stochastic environment. Stochastic environment is an random in nature and cannot be determined completely by the agent. So here the outcomes can involve uncertainty or probability. The same action may lead to different results. So the good example that we can tell it as an Ludo. Since Ludo will be in the picturized, it is given in the example. Ludo, any games that can be involved in dice. Okay, we can take it as a not only Ludo, we can take it as a snake and ladder, we can take it as some other games. So since Ludo is a 4-player game, so there will be often die. So the die consists of the numbers 1, 2, 3, 4, 5, 6. So we are just going to start with the rolling the die. So each and every information that can be with the playing of each and every moves. So that will be often player 1, player 2, player 3, player 4. So the ultimate goal is whenever we are just going to play a die, so which can be often random in numbers or random in nature. That cannot be predicted, and that cannot be determined by completely by the agent. Once the die is it is of 5, we can move 5 steps from the particular Ludo. So this is one of the good example for stochastic environment. The other example that we can tell it as an stock market prediction. So stock market prediction, each and every day there will be of an increase in the fall as well as decrease in the fall. So that is an good example. According to the market price or according to the gold price, each and everything it will be often random in nature. So according to that particular market price, we are just going to buy or we are just going to exchange the dollars. Everything that can be comes with the stochastic environment. The other type of example will be often forecasting. Forecasting in sense we are having of different types of weather climate. So during the summer season also there will be often rain as a chance. Other thing in winter season also sometime it will be often too much of hot in winter season. So this occurs according to the prediction. So whenever the rainfalls will occurs will be of predict that will be of raining for a full day or half a day or a hour. Everything that can be often random. So it is based on the nature. So that cannot be predicted completely by the agent. So, something which can face with the natural disaster like earthquake, everything that can be often nature. So this is about the examples of stochastic environment. Next we can move to the episodic and sequential environment. So episodic and sequential environment, episodic we'll see about it. Only the current percept is required for the action. Every episode is independent of each and other. So we can tell it as an each and every task is independent of the previous task. So decisions making that does not affect the future action. So here in the picturization, it has been represented with the robo picking arm. So that is of part picking robo. So there will be of some current perception will be there. So we will be giving some task to the particular robo. So the ultimate aim to pick the particular robo will be of going and picking the particular robo, uh, picking some obstacles, and it will be of like an hand. So it is of whenever we are just going to give some instruction, the each and every episode will be go there and sense the particular obstacles, whether it is present or there, then it will be of picking the particular obstacle and come back to the particular position. It will be of independent of each other. So there will be of different number of colors of obstacles are there, objects. So it will be of a main thing that is used to pick the particular thing. And the other examples that can be tell with the particular episodic environment is that image classification. So let me take it as an image classification. So according to the leaf, so we'll be using of different types of machine learning or deep learning algorithm for classification. So each and every calculation will be having a advantage as well as disadvantage. So the it will be of each and every classification will be having a each and every episode of independent that can be not dependent on each other. So only the current perception, whatever we are just going to apply each and every image classification or textual classification or voice classification, that can be depend only on the current perception that we are just going to apply of it. We'll be using of some algorithms, we'll be using of some pseudocodes. Based on that will be of determine according to the action. So that is another one example, and another example that we can tell it as an spam email detection. So that is also an current percept that can be required for each and every action. So this is all about the example of episodic will be of an part picking robo, other will be of an image classification, and finally spam email detection. So next we are just going to see about the sequential environment. Sequential environment that will be of an agent that requires memory of past action to determine the next best action. So the current decision could not affect all the future decision. So that is an good example that we can tell it as an example of chess. Since we are just going to there will be of 16 black coins and 16 white coins are there, two player game. So we are just going to move each and every coin over there. So the player 1 will be moving of any coins, and player 2 will be also noting down the particular action what player 1 does, and you will be moving according to it. So whether it cannot be reverses the particular coin, so it cannot be moved to the particular coin, the past in action that can be determined the next best action. So according to the scenario, so the current decision does not affect the future decision. So whenever the past information it will be of done, so we cannot replace the particular coin over there, and we are just going to move concentrate to the next coins in whatever the future moves to make the checkmate. So that is an important concept or scenario that we are just going to consider as the chess game. So it is comes under the sequential environment. So the other will be of an navigation of robo. It is also one type of an good example of sequential environment. Navigation of robo, whenever we are just going to give the instruction, the robo will be moved according to the scenario. So we can tell it as an automatic vacuum tube is a good example. So whenever the past action to be determine the next action, where there will be of an automatic vacuum cleaner, there will be of any dirt or dust will be there. It will be just go and pick the particular dust and it will be inserts to the particular wastage. Once if it is of currentation will be of could not affect. So since each and every places it will be go wherever the dust will be there or dirt will be there, it will be picks the particular dust and store it into the and it will be moved to the particular scenario. So that is an also good example. Other will be of an robo navigation. So this is about the example of episodic as well as sequential environment. And moving to the next environment, it will be often static as well as the dynamic environment. Let me see about the static environment. Static environment, the environment does not change. So static and dynamic. So static, the environment does not change while an agent is acting. So here we are just going to tell about does not change while the agent is making a own decision of it. The good example we can tell it as an crossword puzzle. So crossword puzzle, there will be of some scenario or some statement from left to right, right to left, up to down or bottom to up. It will be given. So automatically that the particular environment while we are just going to play the game, so there will be of some scenario or some statements or according to the puzzle will be given. So according to that it does not change. So wherever we are just going to move from left to right or right to left according to the scenario or statement for the particular problem or the particular decision will be given. So according to that we are just going to set it and we are just going to give the numbers or particular pattern for it and it does not change. So once if it is fixed, so the wordings and the letters that cannot be changed according to the whenever we are just going to proceed with the each and everything. So that is about the crossword puzzle. The other example we can tell it as a chessboard during the player's turn. So each and player 1 and player 2 will be having a turn. So during the player, so it cannot be changed. It is since it is a two player game, so the environment doesn't change. The agent will be acting according to the particular game environment. So that is about the static environment. So next we are just going to see about the dynamic environment. The environment may change over the time. So it can be changed continuously. So the good example will be often roller coaster ride. So taxi driving, okay, it is often good example. So whenever we are just going for any adventurous game, so it will be of setting the time, it cannot be changed over there since it is an very complex and difficult game. So once if you are just going to complete your ride in a roller coaster, so then only it will be completed or else it won't be completed. So that is a good example. The environment may change over the time to time. So or it can be continuously changes with the environment. So other will be often traffic control system is a good example. So whenever we are just going in a road, so there will be often traffic lights. So according to that it will be having a control system. There will be of three colors with the three signals will be there, which will be of red, green and yellow. So according to that, green will be of whenever we are just in a stop position, we can move according to the time. So yellow is going to stop and red will be automatically we are just going to stop over there in a particular environment. So if it is not done, so automatically you will be making of fine. So according to that, so each and every time environment that can be depend, that cannot be changed over because of the environment, that is exactly said to be as an dynamic environment. So the good examples are this one, and autonomic vehicles is also another one example for dynamic environment. So next environment will be often discrete and continuous environment. So discrete and continuous environment, it will be often the environment consists of a finite number of action that can be deliberated in the environment to obtain the output. So in simple, we can tell it as an it will be consist of some states, action or time that can be often finite and countable. So example, we can tell it as an chess. Chess board will be having a timer. So how there will be of 16 coins over there in a player 1, player 2. So how many moves that you are just going to make, it can be countable. It can be a finite. Each and every player that we are just going to move, based on that how much fast that you are just going to perform, and what rating and what pursuing that we are just going to complete the particular winning of a particular game, player 1 and player 2, that can be complete with the that fast, the number of action with the particular moves that can be of discrete environment. So the other examples of an board game. So board game, carom board or some other games that we are just going to use it. So that will be often having a time limit. That will be of having a finite and countable. So how many times that we are just going to play with a white and black coins in a carom board. And once if we are just going to make a red with a black or white. So then finally you are just going to maintain a time at the particular instant. Based on the environment, you will be surely getting the proper output in a discrete environment. Next, we are just going to move about the continuous environment, the environment in which the action performed cannot be numbered. So there will be of not a discrete and said to be as an continuous. So each and every states and action that can take any value within a particular range. Okay, that will be often good example. Self-driving car is a good example. Aircraft control system is another example, and robo movement is one of the main important thing. So that we are just going to perform that the action cannot be numbered. So it will be of going in an forward direction and then backward direction, and it will be of a circular motion. So wherever we are just going to go, that can be often not discrete, it will be often continuous environment that can be performed with the thing. Next, we are just going to move with a single agent as well as a multi-agent environment. Single agent. So single agent is that if only one agent is involved in an environment and operating by itself, then the such a environment is said to be as a single environment. Only one agent operates in the environment. So we can take it as an good example of route planning. Other example of solving a Sudoku puzzle. And the main example, we can tell it as a maze and carrot. So there will be often in the picturization which is given in the particular example is maze and rabbit, maze and carrot. So there will be of different number of parts over there. So the ultimate aim, only one agent will be act according to the single agent. So there will be often chance by going each and every route and finding the destination of carrot. So each and every moves that can be moved according to it, and finally which will be of the best route for finding and get involved in the environment, that will be a best move to finding the carrot. And let me take the real-time example of in the real world scenario. So route planning, we can tell it as a shortest route path, or we can tell it in the terms of data structure, we can tell it as an Dijkstra's algorithm. So it is mainly used to find the shortest path first. So suppose if you are just going to carry one place to other place, so in which route we are just going to have the scenario to reach the destination from source to destination in an easiest way. While you can go via the bus, while we can go via the train, while we can go via the car or any vehicles, in which path, on which route we are just going to start from the source to destination to achieve the it can be of involved with only one agent, and according to the environment and according to the situation or according to whatever the condition, that we are just going to take it as an action and reach from the source to destination. That type of an environment is said to be as an single agent environment. So the example can be of a maze and carrot. The good example will be of an route planning is a good example. Apart from that, we can solve using of Sudoku puzzle. And moving to the next agent will be often multi-agent. So multiple agents are operating in an environment, then such an environment is said to be as an multiple agent that can be interact, cooperate, and even they can complete the particular action to it. The good example will be often football. Other example which can tell to be as a two-player game will be often chess and tic-tac-toe, and online multiple games like Mario or some other games. For football, we'll be having of totally 11 players are there from both the sides. The ultimate goal, you want to put the particular football into the particular goal basket of it. So that is a multiple aim. So each and everything that there will be often communication according to it, and they can be interact and cooperation will be there. So according to that, each and every move will be there over there to the particular environment. So apart from that, there will be of an having of other type of an environment that will be of known and unknown environment. Known environment, the agent knows the rules, outcomes, and behavior of the environment. So each and everything that will be known, player one and player two, wherever we are playing, that will be having a particular knows the rules and regulation of it, and what type of behavior and what type of outcomes that we are just going to face by moving the each and every coins. So that will be of a good example. Chess with the predefined rules is a good example for known environment. Unknown environment, the agent must learn how the environment works through the experience. So exploration of robo, new game playing agent will be often good example for unknown environment. So let me see about the final thing. So that will be often fully observable, can access complete state of environment at each and every point and each and every time. Partially observable could be due noisy, inaccurate, or incomplete sensor data. Deterministic, if the next state of the environment completely determined by the current state and action, that is of agent action. So the example is chess. Stochastic, a partially observable environment that can be also appear to be stochastic, and it will be of the good example for stochastic is weather forecasting. Episodic, the agent experience is divided into independent atomic episodes at which agent perceives and performs a single action in each an episode. So that will be of a good example. We can tell it as an image classification. And sequential, current decision that affects all the future decision. So the example is based on the player 1 and player 2. Then the example is chess. Static, the agent does not need to keep sensing while decides what action to take, does not need to worry about the time. So that will be often crossword puzzle. Dynamic, environment changes while agent is thinking. So semi-dynamic, environment does not change with the time, but the agent performs does. So the good example will be of traffic system with the traffic lights. Discrete, so we already know about the discrete. It will be of a finite state with finite action. What we are just going to perform, the tic-tac-toe or any player games with the two-player game, that will be of discrete. Continuous will be of infinite possible values. The route navigation or shortest path route, which will be of a good example for continuous. Single agent, that will be often only one agent can be occurred in the environment. The example is Sudoku. The multiple agent, we can tell it as an, so agent affect with each other performance measure and operate with the multiple agents of the environment, that will be often multiple agent. So two player game and football is a good example. So as per the final tabular column which will be there, so this is about the each and every task environment observable data according to the environment. We will be having of good example with the particular thing like crossword puzzle, check with the clock, poker, backgammon, taxi driving, medical diagnosis, image analysis, part picking robo, refinery controller, interact engineer tutor. So each and everything according to that what type of environment which will be suits for either fully, partially, sequential, deterministic, full, multiple, single, whatever agent that we are just going to see about it. So we'll be having this type of a environment. So to conclude, so the environment in a AJAI, that is of artificial intelligence, which plays a major role in the world, that the agent can operate by themselves. Understanding the type of environment, it is also helps to designing intelligent agent that can be perceive, reason, learn, and act according to that effectively. Thank you.